Imagine yourself clinging, like a character in a spy thriller, to the roof of a bullet train hurtling along at 150 miles per hour. Your situation is extremely precarious. As you are dragged along, the air resists your passage, and a hurricane-force wind threatens to push you off the back of the train. Your hair flies around wildly as you hang on for dear life. And yet, as you listen to the opening words of this book, you may well have forgotten that you are sailing across the cosmos at 150 miles per second. That's over 500,000 miles per hour. You are carried along with the Earth and Sun in their orbit of our galaxy's center, thousands of times faster than the imaginary train. Nevertheless, you feel no space resistance. There is no space wind blowing your hair about. You travel through empty space as though it's not even there. This wouldn't be puzzling if space were the benign, boring nothingness that we once thought it was. But after Einstein suggested that gravity reflects the bending of space and time, we learned that empty space itself can warp, stretch, and ripple. It is hard to imagine that nothingness could do these things, which seem more characteristic of materials such as fabric or rubber. Yet if space behaves like rubber, why can we move through it as though it's not there? We do have some clues as to how empty space is distinct from rubber, air, or water. For instance, the waves in ordinary materials can always be overtaken. A speedboat can travel faster than ocean waves, and a plane can travel supersonically, outpacing its own sound. But you cannot catch up to ripples of space, known as gravitational waves. This would seem to violate common sense. No matter how quickly these ripples traverse the cosmos, you might imagine that a spacecraft with a powerful rocket engine could relentlessly increase its speed and eventually pass them by. But it just can't be done. Empty space is sort of like an ocean, and yet, in the end, it's not. There's something almost illogical about it. As unusual as gravitational waves are, they're not alone. Experiments have confirmed that light waves can't be overtaken either. Moreover, they travel at the same rate as gravitational waves. These commonalities are striking, and in stark contrast to ripples in ordinary materials. Not only can sound waves, ocean waves, and earthquake waves be outrun, they each proceed at their own clip, as do ripples along ropes and in rubber sheets. So the fact that waves of light and undulations of space share remarkable properties suggests that the two might be profoundly interrelated. Perhaps they are different facets of a single, underlying structure.